Okay, so transfer. Does that make sense why you have to transfer it? Because it's a more precise instrument, okay? Because measuring it in the beaker is precise but not like exact, you know? It's hard to be exact when it's just like a longer, okay? Then you fill the flask to the blank milliliter, which would be the final volume. So in the one that I showed you, it was 100, okay? To that little line where you want the meniscus. So see, this is like a zoom in. See the meniscus? Right at the bottom is where the line is. So the water is kind of curving up because of adhesion, right? The water molecules are stuck to the glass. So you look at the bottom of the meniscus as your line. Oops. Okay, so for example, so you can flip. Okay, so say for example, we're asked to describe how to prepare 100 mils of 0.8 mole per liter solution of potassium permanganate. So we write out everything that we know, okay? So we know we have to have a volume of 0.1 liters. So that's all I can use. My concentration is 0.08 moles per liter. So, and you can find your molar mass of potassium permanganate by using your periodic table, which is 158.04 grams per mole. So I need to weigh out an amount of solid potassium permanganate. So I need to find out how much I'm going to weigh. So what I'm going to do is we use our moles is equal to concentration times volume to see how many moles of potassium permanganate are in there. So M equals C times V. So if I need that concentration and that many milliliters, I know I need to only add 0.008 moles of potassium permanganate. But as we said, we don't have a scale that tells us moles. So we need to convert this value into grams so that we can actually weigh with a unit that we can use. So we use our grams is equal to N times big M. And make sure you're using your little m's and big M's when you're doing these formulas. So my moles times my molar mass. And you get 1.26 grams. So now this is just kind of the legwork to do this. This is just the calculations, but they're not done here because let's read the verb that it gives us in the question. Describe, okay? When we look at our words here, okay, where do you think describe? Is there a describe on here? Oh, it's on the yellow one. Goodness. I almost feel like describe should, well, maybe not. I guess it's a yellow one, but we actually have to describe how to do those things. We can't just do the calculations and stop there. And a note on your assignment, there was one question where, what did I say? Oh, the verb was explain, so anyways, I should have told you that later when I passed it back to you. But some of you lost marks on that just because I wanted a little bit more, because the verb there was explain. So anyways, stop talking. Okay, so you have to say, and you have to write this out. Number one, measure out 1.26 grams And if you run out of room, you can put it below there too, where it has the demo stuff. 1.26 grams of potassium permanganate solid. You can write the chemical formula. What does that bell mean? Huh?
That's like end of the first page.
Okay. Dissolve potassium permanganate in 50 mils of distilled water, because it's half of what it should end up as being. Okay? If you end up dissolving it in a little bit more, that's okay, because once you put it in your volumetric flask, you just fill it up to the line, you know? So it doesn't have to be exactly 50 mils, but it's like about. And then you make sure it's kind of mixed up. And why is it distilled H2O? Why shouldn't I just get it out of the tap? Yeah, definitely it has other ions in it that will react, and so it's definitely not a pure substance or a pure solution at all if you use tap water. Transfer the solution to a 100 milliliter volumetric flask. And then the final step is to fill to 100 milliliters, and you can, and then put the cap on before you turn it upside down. Don't just dump it out on the floor, right? And then you just invert it and you can mix it up. Bunch of caps. Okay, before I demo, we're just going to review some lab equipment.